Hey guys, welcome to our channel. So today we will introduce the fundamentals of MLOps and discuss its significance in the development and deployment of robust, scalable and efficient machine learning solutions. So MLOps, which is short for machine learning operations, is basically an engineering discipline that aims to bridge the gap between machine learning development and operations. It involves the collaboration of data scientists, machine learning engineers, and operation professionals to streamline the process of building, deploying, monitoring, and maintaining machine learning models in a production environment. The purpose of MLOps is to ensure the successful deployment of ML models, minimizing the gap between experimental models and models in production, and to manage the life cycle of the ML models effectively. Now, the question arises, why is MLOps important? So, as machine learning is becoming increasingly critical to business success, organizations need to ensure their models are accurate, reliable, and up to date. MLOps addresses this need by reducing the time it takes to deploy models into production, then ensuring consistency, reproducibility, and traceability in model development, monitoring model performance and managing updates, facilitating collaboration between data scientists, engineers, and operations teams, complying with regulatory and ethical requirements. You must be thinking now, how is it different from DevOps? So, first difference is focus. So, DevOps primarily deals with the development, deployment, and maintenance of our traditional software applications, wherein MLOps is specifically designed to manage the unique challenges of ML model development, deployment, monitoring, and maintenance in production environments. Next difference is in the development process that they follow. So, the development process in DevOps is usually deterministic, meaning that given the same input and code, the output will be consistent. Whereas in MLOps, the development process is non deterministic due to the inherent nature of ML models, which actually depend on data and can produce different results with the same input or even the same data. So, the next difference I would say that in DevOps, data management is typically not a core concern as it mainly deals with code and infrastructure, wherein in MLOps, data is a critical accept. So I would say, like, as ML models heavily rely on data for training and evaluation, MLOps involves data versioning, data preprocessing, and data validation, among other data related tasks. So, in summary, while DevOps and MLOps share the goal of streamlining development and deployment process, they differ in their focus and approach. DevOps is mainly centered on traditional software development, while MLOps deals with the unique challenges and requirements of machine learning model development and deployment. Now, let's talk about the ML project life cycle. So, all the steps involved in the ML life cycle are required for the successful development and implementation of ML models. It is basically a cyclical process because the process is actually continuous and repetitive. So let's go each of the steps here one by one. So the first step is business objective, or we can say as problem statement. So, like any other good business life cycle, the data science life cycle also starts with why we need it. If business requirements are not clear, it will be futile to go for further steps. In short, understanding business needs and knowing the customers is essential to build an accurate model. So, the next step I would say would be data gathering. So it is it's like, I would say, like data is like a fuel for a machine learning algorithm, and it may be collected from different sources, but we need to make sure that we collect data which is actually relevant to the business need. The data captured can be either in structured or unstructured form. So, data sources can be like logs from websites or social media data, data from online repositories, and even data streamed from online sources through like APIs, web scraping, or like the data that could be present in Excel or any other source. So now the next stage would be data preparation. So once the data is collected, it is very important to clean and pre-process the data to get accurate results from our model. So converting the raw data into a usable format is the base of this step. So it would be like, it would involve missing value treatment or checking out improper data type or invalid data, then examining null values, like eliminating any duplicate records, and like can be any other steps as well which would actually help us in cleaning the data. Now, moving to next stage, which is exploratory data analysis. So, in this step, we would be exploring the data deeper for better understanding of the data. So, it is a critical step in gaining some ideas about the solution and factors affecting the data science life cycle. The key aspect to remember here is that your input determines your output. So, in this section, the data prepared from our previous stage will be actually explored further to examine the various features and their relationships, aiding in better feature selection required for applying it to the model. So, next phase, which I would say is actually the major phase of the data process and is actually like mentioned as the heart of the data analysis, which is model building. So now a model should use prepared and analyzed data to provide the desired output. So in this phase, the team works together to develop data sets for training and testing the model for production purposes. It also involves various tasks such as choosing the appropriate mode type and learning whether the problem is a classification, regression, or clustering problem. So it has to be done carefully, since extracting necessary insights from the prepared data is extremely important. Now, like once the model is trained, it's very important to analyze the performance and accuracy of the model as well. So the main goal of any machine learning project is to achieve maximum model accuracy. So like currently there are various evaluation criteria like accuracy score, precision, recall, F1 score, ROC curve, like etc. There are many actually. So based on this, we can select like which is the best model. So moreover, like overfitting and underfitting problems are also addressed so that the model performs well with the new data. So now we are at the final stage of the life cycle of data science, which is model deployment. So like after a rigorous evaluation process, the model is finally prepared to be deployed in the desired format and preferred channel. We all know there is no value for the machine learning model or actually any software until it is deployed to production. So in general, these models are integrated and coupled with products and applications. So like now just let's talk about what we call ML algorithms that are available. I would be here just covering the basics ones, not delving into all the algorithms. So maybe we can take that up in our next sessions. So, machine learning algorithms can broadly be divided into three categories based on their learning approach. So, the first one is supervised learning. So, here the computer learns from examples that include both input input data and the correct answer. So it's like a teacher providing the right answers while the computer practices solving problems. After learning from these examples, the computer can make predictions for new and unseen data. So let's take an example. Imagine you have a basket of fruits and you want the computer to recognize whether a fruit is an apple or an orange. You show it labeled examples of apples and oranges, and the computer learns to recognize them. So, basically, classification and regression falls under this learning. So, the second one is unsupervised learning. So, in this technique, the computer learns from data without any provided answer. It actually tries to find patterns or structures within the data by itself. It's like the computer exploring and organizing the data without any guidance. For example, suppose you have a collection of news articles. You want the computer to group similar articles together. So the computer analyzes the contents of the articles and finds patterns to cluster them into different topics. So basically, the clustering algorithm will fall under this technique. Now, the third is reinforcement learning. So, in this technique, the computer learns by interacting with an environment and receiving feedback in the form of rewards or penalties. I would say it's like a trial and error process where the computer learns to make better decisions over time. So, let's take an example. Imagine teaching a computer to play a game like chess. So the computer learns by playing multiple games and it receives a reward or penalty based on the move it makes. Over time, the computer learns to make better moves to increase its chances of winning. So now moving to the standard ML pipeline flow. So a machine learning pipeline helps automate machine learning workflows by processing and integrating data sets into a model, which can then be evaluated and delivered. A well-built pipeline helps in the flexibility of the model implementation. So there are various stages in a machine learning pipeline architecture. So here in the diagram, we have the major stages. So each stage of the data pipeline passes processed data to the next step. So go through each stage. So the first one is data processing. This step entails collecting raw and inconsistent data selected by a team of experts. So the pipeline processes the raw data into an understandable format. Data processing techniques include feature extraction, feature selection, dimensionality reduction, sampling, and many more. So the final sample used for training and testing the model is the output of this stage, which is data processing. Now, moving to the next stage, it's model training. So selecting an appropriate machine learning algorithm for model training is crucial in a machine learning pipeline architecture. A mathematical algorithm specifies how a model will detect patterns in data. So next stage is our model evaluation. So the sample models are actually trained and tested on historical data to make predictions and choose the best performing model for the next step. So which is basically the model deployment. So this is our final step to deploy the machine learning model to the production. So ultimately, the end user can obtain predictions based on real-time data. Now, talking about the ML pipelines tools and frameworks available that can help you create and manage machine learning pipelines. So like these tools automate the whole pipeline process, making it more efficient and easier to develop, train, and deploy ML models. So here we will be talking about some popular ML pipeline creation tools. So the first is Azure Machine Learning. So it is actually a cloud-based service by Microsoft that provides tools for building, training, and deploying ML models. Next is our AWS SageMaker. So again, it is a cloud-based service from AWS, and then like we have another one which is being offered by Google Cloud, that we call as Google Cloud AI platform. So next is our TFX, so which is TensorFlow extended. So it is actually an end-to-end platform for deploying production ML pipelines. So it is designed to use with TensorFlow but can also be extended to other ML frameworks. Like we also have another which is basically an open source project, that's Kubeflow, which actually again it also aims to make deploying, monitoring, and maintaining ML workflows. Basically it helps maintaining on Kubernetes. So it's very like I would say easy to use, and it provides a set of components and tools for building scalable and portable ML pipelines that can be run on various platforms, including on premises and in the cloud. So we also have MLflow, which is again an open source platform for managing the end-to-end machine learning lifecycle. So like within the same line in the open source platform, there is another which is h2.ai. So like as I said, there are many others in the market available for like for ML pipelines, for creating ML pipelines and managing them. So yeah, you can explore further. That's all we have for today's session. For next session, stay subscribed to our channel. Thank you.